Welcome back to this lesson. So in this lesson, we want to continue with discussion on agentic AI product management. And the session we are now is the slide we are currently is separating planner and executor prompts. In the previous lesson, we ended at managing hallucination by setting constraints so that groundedness, negative constraints, and inference confidence scoring. Please, if this is your first time of coming to our channel, please kindly like and subscribe so you can get more video from us and also learn from us, and also encourage your girl. Please encourage your girl, okay? Like and subscribe so my the channel can hit the number of hours and the number of subscribers that I need to hit. Thank you very much for doing that. Okay. So let's continue with what we have: separating planner and executor prompts. So there's a planner, there's a prompt that is called planner prompt, and there's another one called the executor prompt. So we've discussed chaining in the previous video, and you see how you can also use example, few shot and zero shot in those examples. So how do you separate planner and executor prompts from each other? So the planner prompt identifies the strategy but doesn't touch the tools. Okay, so the planner prompt only plans, just like you have in what we are discussing now is a agentic AI product manager. What you do is plan, you gather the business problem, pain point, business objective, and then you give the software architect who turn the business objective into architecture, layered architecture, and they architect the business, turn it into a technical diagram, and then those architecture are then handed over to developers who develop, and then the production engineer, the DevOps, they deploy the model into a platform for production, and then the users start using it, and then you go again and they gather feedback. So you are not the one architecting, you are not the one developing, you are not the one deploying, but you are the one overseeing the whole product development process. You are the one managing it. That's why we call it product manager. The same thing in project. Manager manages project. Then even as a project manager, you work with stakeholders. Okay, you work for example, I've had many data engineer projects, not as a project manager but as an engineer and an architect. So I design the architecture, I implement the development, extraction, transformation, and loading, and then governance, and then I give access and I report to the project manager who oversees the whole activity and ensure everything is going well. So that is an example of what a planner agent does. So a planner agent doesn't execute, it only plan and identify strategy of delivering the task or delivering the job to the best of its capacity. Then we have the executor agent. So this takes the strategy and calls specific API. So executor agent gets information from planner agent, and then it acts on the strategic information. Remember, everything coming from planner agent is already strategic. It is logical and it is grounded with relevant information that pass on to the executor agent, which then executes its act call API in order to see that the action is done. So when it's done, calling API, calling functions that will solve the problem, routing, and using MCP and everything. When the task is executed, then it sent the output of the task to the reviewer agent. So the reviewer agent will now compare the plan to the execution. The reviewer agent will get the strategy, the plan, and the process from the planner, and then compare it with the output of the executor, whether it is actually accurate or meeting the goal of the business. So reviewer compare the plan to the execution to ensure goal alignment. Remember, we said from the beginning that you don't design for task, don't design task, design process. So don't, as a product manager, don't manage task, manage process. That's why you have architect, you have developer, you have delivery, you have quality assurance, you have business stakeholders, and then you have all of them. And then you are just overseeing the whole of the process of developing and delivering the product. So also in agentic system design, you don't combine all tasks to one agent. No, break tasks into pieces, into processes, and then let agent undo one process after another. Okay, so there's a planner agent, there's an executor agent, there's a reviewer agent. And then here, by implementing this, you'll have a clear separation of concern. All right, the next slide we have here is RAG ground model in current knowledge. So we've discussed RAG system many times. That we say RAG is a database, is a vector database that contains chunk, index, and embedded data, which is being retrieved using either keyword search or semantic search or both. And when both are used, it is called an hybrid search. So I'm still going to do a video on RAG where we'll see how RAG is being ingested into vector database and how it is being received using cosine similarity or Euclidean metrics. So here, RAG normally ground models in current knowledge. RAG ground models in domain knowledge, in business expertise knowledge, or in a particular knowledge that the system is using. So beyond training data, RAG assess facts that happen after the model was trained. So RAG enable the agents to add business information, business metric, business files, business metric calculation analysis, or the business relevant database and numerical description, everything to operate and to act and to perform its activity so that it doesn't hallucinate or use general knowledge. Okay, so beyond training data, assessing facts that happen after the model was trained, you need a RAG. Okay, so current knowledge is RAG knowledge is very important. Private data, so using company specific policy and customer records safely. So you need to use RAG. If you want to use private data, remember LLM is trained on open source data. So to use private data, you have to develop a RAG database. And then RAG, as we have said many times, reduces hallucination because it grounds the LLM information with company data, with domain data, and it enables it to give you facts instead of generating general information from or generic information from the open source knowledge on which it is trained on. So forcing the model to look up the answer before speaking. So the answer, when you use RAG database, the model doesn't just speak from general knowledge. It doesn't just speak from generic knowledge. It uses what it has in the RAG database to fine-tune the output of its own information and then model the output to to be conformed to what is in the RAG database and give you output. And then you have a reduced hallucination. There can still be hallucination, but it is reduced to the barest minimum. Okay, so the next slide is talking about semantic retrieval through vector embeddings. So we just talked about RAG database. Vector embedding is a process of creating a RAG database. As we have said many times, when you get the data, the next thing is to chunk the data, the next thing is to index the data, the next thing is to embed the data in a vector database where the LLM can retrieve the data to augment information. So semantic retrieval through vector embeddings. This is finding information by meaning, not just keyword. Okay, so we have said keyword is find information using keyword. It doesn't use coordinate. It doesn't use numerical distance or numerical ranking or maybe cosine distance to find distance. No, it uses keyword. But to find meaningful information, correct and accurate, excuse me, correct and accurate information that is relevant to the system, you can use semantic search. So semantic retrieval use vector embedding. It uses vector distance or Euclidean distance to retrieve information instead of just retrieving based on keyword. And to do that, we have numerical meaning. So when data are embedded, they are assigned numerical meaning, numerical coordinates, maybe 3-dimensional, 4-dimensional, 5-dimensional, etc. They have numerical number assigned to them, and the numerical number is unique to them. Then we have example. So they can also retrieve based on example, and they can also retrieve using similarity search. So by searching for what is similar to the question, and then they gather all the similarity together, combine with example, combine with numerical meaning, and then everything together. The intersection of these three is called semantic retrieval. So combining numerical meaning with similarity search with example search, you have semantic retrieval. So by doing this, by combining these three together, you have a kind of personalized information that is applicable to the person using the agent, or that is applicable to domain. So this will enable you to generate original domain information relevant to to solve the business problem. So that is what vector embedding are. So for vector embedding, we have several of them. So maybe we should just quickly look it for people that are mathematician in the house. So there are two ways of performing vector embedding. The first one is Euclidean distance. Okay, the distance between x and y equals to square root of x squared plus y squared. Okay, x squared plus y squared, which is the same thing as computing something like s2 minus s1 squared plus y2 minus y1 squared. So this is the mathematical meaning of that. So when you get information from here and there, and then you combine them together, you have what we call distance between 2 points. Okay, and then we have the cosine. So this is cos theta, which is angle between them, is normally a dot b all over magnitude of a magnitude of b, where a can be a vector of the form x comma y, s1 y1. B can be a vector of the form so if B can be a vector of the form, sorry, I want to clean that off so I can have something. So B is equals to s2 y2. Okay, so they are both vector, and their distance, uh magnitude of AB is AB squared is x2 minus s1 squared plus y2 minus y1 squared. Okay, and then if you take the square root, it is still the same thing as this. So these are ways of this is how to compute similarity search or semantic search. And this S1 and S2 are the numerical value assigned to a particular information or a particular keyword or a particular sentence in the vector database. So the most accurate one is normally considered as this cosine distance. Okay, and then if it is 0, if a dot b is equal to, for instance, it's equals to 0, you have a 0 over this, and then you have 0. So cos theta equals to 0. So theta equals to cos inverse of 0, and cos inverse of 0 is normally equals to what? uh, that 90 degree or something. So but you just have the answer, and then you have the right information. So this enables a RAG database to give accurate information. So the RAG pipeline, how is the RAG pipeline designed? So that's why we are here. Remember, of course, we'll be talking about the RAG pipeline several times. We've not only combined them together to form a process. So RAG is also a process. Okay, it's not a task, it's a process. So the RAG pipeline architecture looks like something like this. So the first thing to do in a RAG development is to ingest and chunk data. Okay, so ingest data means getting data from various sources, including their metadata, into a lakehouse or a database or where it can be accessed. Then this next thing is chunking, which is breaking documents into small readable pieces, small retrievable pieces. And when you are breaking them, you also still be very, very careful so that you don't chunk information away. You don't chunk unrelated information together. Okay. And then the next thing is vector storage. So vector storage is where the data that is being chunked here, all the information that has been chunked in this step, they are indexed and stored as an embedding in a vector storage. So storing this chunk in a database like Pinecone or Weaviate or ChromaDB, pgvector, Azure AI Search, Azure CosmoDB for RAG, and Azure SQL database also now support RAG. So of course, if anyone has written DP 800 in the house, you now understand that Azure SQL database has the capability of storing a RAG, being used for a RAG system now. So the next thing is vector storage. Then after vector storage, we have a context assembly. So context assembly is choosing the top 3 to 5 chunks and adding them together. So context assembly is assembling what the information that has been chopped and stored and indexed and stored in vector. So assembly is bringing related information together. It's bring them together. If A is related to B, A and B are moved close to each other. If X is related to Y, X and Y are moved close to each other. So choosing top 3 to 5 chunk and adding them is called context assembly, because when you have A, B, C and they are very related, you can add them to form one information. That is context assembly. Then generation and citation. So the next thing is ensuring every agent answers cite its sources. So every agent can have access to the RAG database, or RAG database can be domain based, so that domain agent will have access to the RAG and retrieve information from them. They will not act their own, they will not operate on their own. They retrieve information from the system in order to perform their activities, thereby generating facts and valuable information for the business. So the RAG pipeline comes from starts with ingestion chunking to vector storage to context assembly and to generation and citation. All right, what we have next here is retrieval quality drives generation quality. So remember, it is what you store in the RAG database that your LLM will still use, generate for you. So if nonsense is stored in the RAG database, the LLM will use the nonsense and then give us nonsense. So that is why you should be very careful too when you are implementing chunking. So chunking must not be, must not be generic. It must be done carefully and make sure they are context, context gathering. So context, related contexts are gathered and added together so that the LLM can retrieve grounded information, original fact from the RAG database. So retrieve quality drive generation quality. So how do you improve generation quality? First, you must know that whatever you put into the system is what you get out of the system. Garbage in, garbage out. Okay, CSA 101. If retriever finds the wrong page, the LLM will give the wrong answer. Okay, so know that very well. So chunking strategy. So you should decide if chunk should be by paragraph, page, or semantic shift. So decide whether chunking should be by paragraph, should it be by sentence, or should it be by phrase, or should it be by page, or should it be by semantic shift. So the chunk that is really relevant for one data may be relevant for another data. Okay, the chunk, for example, that is relevant for numerical data may be irrelevant for text data. So chunk based on the information, based on the data type and file type. Then re-ranking. So this is using a second slower model to pick the very best chunk from the top 20. So you can use semantic ranking here. So semantic ranking use slower model to pick the very best chunk from top 20. So when you have top 20 chunk, you implement semantic ranking, which is semantic ranking is just combining these three that we have here. Yeah, Semantic ranking is using numerical meaning with similarity search with a sample to select the best chunk and then combine them to form context assembly, and then you can re-rank them. So this is using a second slower model to pick the very best chunk from the top 20. So this is how you can improve generation quality for an LLM. So chunky strategy. Decide if chunk should be by paragraph, page, phrase, or semantic shift, and then we rank. So use slower model to pick the very best chunk from top 20. So we have hybrid search. So I've been talking about this of several times. Hybrid search is combining keyword search with semantic search. Semantic search uses numerical approach to retrieve information from the vector database. Keyword search uses keyword to retrieve information from a vector database. So the first one, keyword search, also known as BM25, is essential for finding specific school numbers or name. So if you want to find keyword, maybe the name or a particular number or a particular word or a particular business metric, you can use keyword search. Then semantic search is essential for understanding general intent. So if you want to understand general intent behind a particular statement, particular sentence, or a particular action, and you want it personalized, then you can use semantic search. And then you have metadata filtering. So this is limiting search to only contract signed in 2024. So you can limit search to a specific information or a timeline or a time-based information or particular range of data. Then we have Cadaba standard. So in Cadaba, we always combine these to ensure zero miss retrieval. So Cadaba doesn't just implement semantic search or keyword search or limit to hybrid search because they are combined together and leave metadata or filtering. No, Cadaba implement everything to make sure that what is given, even if it is not 100% correct, it should be at least 99.99% accurate. Okay, so Cadaba implement all of this together. So we have GraphRAG. So RAG database uses the normal database. It uses vector database, while GraphRAG use graphical relations, the graphical or connected knowledge. So GraphRAG are connected. They are like graphical database that connect information together. It connect related information together, just like you have a geographical location. So everybody in geographical location, they tend to do maybe they are bounded. So you have your friend in maybe street A, street B, house A, house B, and all of you just live together in that environment. And then if anything, if you want to have friend there, you have friend maybe in the second house, and everybody is related. And then you, for example, in a family, you have siblings. You have those that are close, those that are not close. You have those that are close because they value the same thing, and those that are close because they like the same thing, and so on and so forth. So relationship is forming relationship between data, okay, connecting them together based on how they are related is called graph or GraphRAG. So it's used for connected knowledge. An example of GraphRAG is also, I think with it is being used to, but Neo4j is another one. Neo4j is a graph database that can be used for GraphRAG. So beyond chunk, mapping how entities, users, product, rules relate to each other. Okay, that's GraphRAG. So it's find how entities, how words, how keywords, everything relates to each other. And then explainability, tracing the reasoning path through knowledge graph. So before an agent retrieves information, when it gets from what it has retrieved from the user input, it generates entities from there and relates it to the information, to the related information in the GraphRAG database before it generates outputs. So this enables retrieval explainability and context understanding. So tracing the reasoning path through a knowledge graph, and then complex reasoning. So GraphRAG is used for complex reasoning where RAG database is not enough. So answering how does rule X affect department Y? So this will relate rule X, it will map rule X to department Y, generate relationship, an answer based on the relationship. So GraphRAG is used for complex reasoning and complex activity or complex retrieval. Then the next thing we have on this slide is a Cadabra Enterprise Memory layer. So for Cadabra Enterprise Memory layer, we have the core knowledge layer, which is where you store all the company policies, manual and market data. Okay, it can be files. This database can be in form of files, can be maybe a document. So you can use blob storage for this, just to store file, or file storage. A SharePoint can be used, or Lakehouse can be used as well, or Azure Cosmos DB for storing document or JSON format data can also be used for this. So these are document storage per se. And then we have episodic memory. So episodic memory is a kind of historical memory. It stores what has happened in the past. So it stores history of past interaction with a specific user. Okay, it stores history of past interaction with the user that accessed last year, last month, and everything. So it stores interaction or with former user, or with any user at all. Any former information that the system that has entered the system or come out of the system is stored in episodic memory. So just like an historical database, but for RAG. And then for agentic AI system, then we have organizational memory. So this is a collective outcome of all agent decision across the company. So this organizational memory can be seen, or can be seen as the database of every agent. Remember in design, in my course or book in multi-agent system, I discussed that every database, every agent should have their own database. So the database, if you have 10 agents, you should have 10 database, specialized database for each agent, so that agent information will not be mixed up, and then you can trace a particular outcome to a particular agent by accessing their database. So combination of every agentic database forms what we call organizational memory for the agentic AI system. So the enterprise memory layer are core knowledge, and the episodic and the organizational memory. The managing context window limits. How do you manage context window? We have said context is combining several keywords or several semantic search to form a meaningful information because they are related. So how do you manage context window limits? The problem, you can't fit a 500-page manual into one prompt. Just know that. Okay, so no, that's why we say we use to chunk data strategically. So know whether you should chunk a sentence, you should chunk a page, or you should chunk a particular paragraph, and so on and so on. But do not fit the whole explanation into one prompt. Okay. We've also talked about chaining prompts, where you break down a whole prompt into steps and then combine the steps together to be implemented by the AI. So the solution here, the solution to this problem of large database or large data file is to implement summary-based retrieval and tiered context, e.g. we have gold, silver, bronze level. So in data engineering, we have the medallion architecture that we call the bronze, silver, and gold, which is raw, process, and transform data. You have the raw layer, you have the process layer, and then you have the modeled layer, so which is the gold layer. So also you can implement that for RAG. Okay, you can have your bronze level, which is where you have all the raw data and the metadata. Then you have the silver layer, where they are chunked into maybe pages. If you have a very large document, you can chunk them in. At the silver layer, you can jump into pages. Then at gold layer, you can chunk from pages into paragraph or sentences. So you can also implement this for a rack system. Okay, then we have cost impact. So smaller, higher quality content leads to cheaper, faster agent. So if you implement medallion architecture for a rack database design, what you'll be designing is you'll be minimizing output and you'll be minimizing cost and maximizing output. Because why? The LLM will not use a large token to retrieve from gold layer. The level of token needed to retrieve from bronze is not the level of token needed to receive from gold, because the gold layer is now refined and it is now simpler and easy to understand and to quickly go through. So implementing medallion architecture for RAG database design will reduce token usage, give higher quality context, leading to cheaper and faster agent implementation and design. Freshness and decay and data decay in RAG. So how do you ensure freshness, that data is fresh? How do you ensure that there is no decay in the RAG database? The first one is dynamic ingestion. So update the vector store every time a document is changed in a SharePoint. So this is also very important. So that means RAG database should also be fashioned so that a CI/CD pipeline is triggered whenever there is a new document in the database, just like you have in data engineering. Okay, so version control, ensure agents don't cite obsolete policies. So there is always a redeployment into the production whenever there is a new file in the database. Cache management, so storing common query results to save on retrieval cost. So when you implement cache, you will save retrieval cost, because if everything is stored in the RAG database, which is historical, or episodic database, which is historical, every time an information needs to be retrieved, the agent will use an LLM token to go and search through these databases before retrieving information. But if immediate action, working information are stored in cache, it can easily be retrieved from cache whenever it is needed for a particular information. So, but when they are now becoming maybe 5 days old, 10 days old, they can be moved into RAG or other database. So implementing cache using Redis cache or Azure Redis cache or any cache database in any cloud you are using improve retrieval and also minimize retrieval cost. Okay, fine-tuning changes model behavior deeply. So we've talked about fine-tuning, that it's help you achieve a maximum correctness from agentic AI system or in even AI design. So fine-tuning changes model behavior deeply in the following ways. The first one is beyond context. It teaches the model a new instinct or way of thinking. So fine-tuning is teaching the agent to behave in a particular way. Okay, if you give that to a child when it is 1 year old, you begin to teach the child what is right and what is wrong. You begin to teach the child what is good and what is bad through continual or through reinforcement learning. So you know that reinforcement learning uses reward. So it rewards the agent for doing what is good and then penalize the agent for doing what is bad, or subtract points from the agent for doing what is bad. So that can also be implemented here. So beyond context, teach the model to do the right thing. Teach the model how to think, teach it how to act, teach it how to, generate response. Okay. Domain specializing, deep understanding of medical, legal, or banking jargon. So the we've said bounded context many times. Bounded context is limiting the agent to a specific domain knowledge operating within the business domain. So you can use domain knowledge, domain business metric, or particular domain metric, domain information to train the model so that the model is grounded in the knowledge of the domain. For example, medical agent, you can teach the agent all medical jargon up to a professor level. Then legal agent, teach the agent every legal vocabularies, every legal word, legal phrases, every term used in legal definition up to professional level. And then we have banking jargon, do the same thing. So instruction follow, improving the agent's ability to stick to a complex output. It's called instruction. So give the agent, instruct the agent to stick to a particular output all the time, so that instead of giving you a legal information when you are requesting for medical information, it just stick to legal information, not medical information, and it doesn't go outside the context. So when to prompt, when to RAG, and when to fine tune. So we'll look at 3 of them. when should you prompt, when should you use RAG, and when should you use fine tuning? In agentic system design, if you have read any book on it, so if you've not read a book on AI engineering, I think you should study one as well. It's very, very important. All these terms are also there. So according to Chip Uyen's book, he say you should use prompt before RAG. If prompt is not enough, you move to RAG. If RAG is not enough, then you fine-tune the model. So that is the process. Always start AI engineering. After deploying foundational model, the first thing you should do is prompt. Design your prompts. Start from few shots, or start from 0 shot to few shots to chain of thought, and then to tree of thought, and then choose the best that work. So method, use case, implementation speed. Prompting is used for designing agent persona and tone. Okay, just like you want to design an agent for a supply chain manager, you will use the vocabulary, every tone and jargons of the supply chain manager to define the prompt so that the agent itself become a supply chain manager. So implementation speed, this prevent hallucination by performing actions in minutes and generating facts. RAG. So RAG offers dynamic and changing, RAG improve dynamic and changing facts. So if a prompt is not enough, then RAG contains historical information about the particular domain as well. So it is in addition to prompt, it will go to RAG database to generate facts that are related to the prompt, and this can take like implementation speed can take like this, because you can do a prompt in 30 minutes and then build your agent. But to develop your RAG database, you have to determine all your source of data, ingest and process them, and chunk, reindex and embed them, and store in a vector database. Then you now need to design an API or MCP that will connect to the RAG database through an API to retrieve information. So you can take this. Then fine tuning. So this is deep skill, teaching the agent how to behave, teaching the agent how to perform tasks, teaching it how to generate instruction, what format is you use, what style, paragraph style, sentence style, tone, and everything, and teaching it as well to aim to work within certain guardrail, not to perform a task, not to misbehave, not to, the way to answer so that it doesn't go outside the business context or the business boundary. So fine tuning, this skill, style, and logic. So this can take weeks, because you can't teach an agent in 1 week. Just like if you want to become a medical student, you don't just go to school 1 year and become a medical student. Minimum of years spent in school is like six years. So you can't teach an agent in 1 minute or 1 day. No. So it takes several weeks, even not several months, to teach an agent. For example, I was using Fable. So Fable was telling me that it was developed like June last year. But I said you were, rolled out June 6th June this year. Said no, it has been developed since June last year. It was developed in June 2025, but was being continuously trained, fine-tuned for a year before it was now deployed in June 2026 and made available for the public. So that is fine-tuning. It can take months to achieve. Then domain specialist language. So using domain specialist language also help to improve fine-tuning. So when you want to fine-tune a model, you use domain specialist language. For example, if you are designing for bank, if you understand labor, escrow, KYC, in contents, loan, interest rates, conversion rates, all those things should be the language it should be trained on. Then energy, if you are designing for oil and gas, for instance, and then you know that within the oil and gas company, there are different domain and departments. So knowing the difference between kilowatt and kilowatt hour too is very, very important. So you use energy or oil and gas vocabulary. Then if you for every company style, adopting the specific professional voice of Cadaver. So Cadaver should cognitive architecture should be adapted to every specific company style, specific professional style, so that it doesn't, operate outside the business context. So we have instruction fine tuning for reliable workflow. How do you fine tune instruction for reliable workflows? So the first thing we have here is task clarity. So task must be clear. It must not be ambiguous. Okay, it must not be vague. So teaching the model to always output valid SQL or JSON is very, very important. Task clarity and prompt clarity, and even if using chain of thoughts, the thoughts should be clearly combined together in sequential. So what should come first should not come last. Safety refusers, training the model to say no to specific harmful requests. For example, if if you are asked to eat something and you don't like it, the next thing should be to say no. Or if you are asked to perform a task, you don't like it, what you should shout out is no. Okay, you should not you should not agree to do what is beyond your ethic or principle. So those are guardrail and safeguard rules should also be included in fine tuning. It should be used in fine tuning. The agent should be taught to say no to specific action. For example, in Claude Code, if you are coding and then you put your password for it to do something, it will immediately tell you that I can't do this. It's not fit, it's not safe for you. So quickly go back now and change that your password and delete it from the system. That is what it will tell you. It will never use your password to do things on your behalf that it shouldn't do. And it will never even accept your password in the first place. And even when you put it in, it will advise you to go and change it immediately. And if you come back, you haven't changed it, it will still advise you to go and change the password immediately for safety. So safety reviews are training the model to say no to specific harmful requests is very, very important. If not, all these hackers can use the agent to hack into database that should not access, to hack into system, or to dupe organization, or because of unnecessary freedom that the agent have. Then we have process adherence. This is ensuring an agent follows a 7-step SOP without skipping step. So agent should follow 7-step SOP. It should follow it should follow process steps. Okay, it should follow step one after the other and should not skip any step. So it should adhere to process. And that is why, as a process, as an agentic system design as well, you need to understand business process management. How do business manage their processes? You need to understand process mining and process intelligence. So which combine to business process management, because everything in enterprise system is a process, and then the agent must also be taught to adhere to the process. It must not operate outside the process. And then we have data set quality outperform raw volume. Okay. So data set quality outperform raw volume is what we have on this slide. So I think we should take a break now. So when we come back, we'll continue with data set quality outperform raw volume. So thank you for listening. Hope you enjoyed the lesson. Please kindly like and subscribe to encourage your girl so that you can see more of our video online.